Hello, welcome to this lesson of Mastering Java. Here we're going to learn how to continue using the math functions, the built-in math functions, and what we're going to learn now is how to take powers of numbers, in other words exponents, and also square roots. So let's jump back to our document that I showed you how to navigate to on the Oracle website. Here are the methods in the math class, and if you scroll down, there is a method under P. These are in alphabetical order, so go up to P. There's POW, and that stands for power. So it says it returns the value of the first argument raised to the power of the second argument. Notice that it tells you that in order to use the power function, you should pass it a double number, which is a decimal point number, and then you can have another double number there. So the way this would work would be number A raised to the power of number B. So if you wanted to do 3 squared or 4 squared, then you would have a 4 up here and then a 2 there. So it's the first number raised to the second. Now it tells you that you have to pass double numbers there, but it works fine if you pass it just integers as well, and I'll show you how that works here in a minute. So here we have a blank canvas here, and if we wanted to just show you how this works, we could say system.out.println. Open this guy up. Inside here, we can just pass a calculation. It's going to return a number, and that'll be handled by the printline function or method to output that to the screen. So as always, we have to use these math functions by referencing the class, which is the math class dot, in this case, POW. Notice it's trying to tell me that here's a method here called POW, and it's a method, so we're going to open a parentheses. Notice it's asking for argument 0 and argument 1. It's trying to tell you that the power method requires 2 arguments, and here's what they're called here. So I can just kind of get rid of all that stuff, and I can put my own numbers in there. So for instance, if I wanted to calculate what is 3 squared, then you do 3 comma 2. So it's the first number raised to the power of whatever the second number I have in there. So 3 squared, this method is going to return a number which is then dumped into the print statement, and that's why I can do it like this. So let me go and hit save. And the answer is going to be 9 because 3 squared is 9. Notice that the result comes back as a decimal point here. So let's go back in here, and you can see when you're looking at the power method here, it requires number A, which is supposed to be a double, which is a floating point number, and also a number B, and it tells you it returns A raised to the power of B here as the answer. But notice over here, don't worry about static. Look at the second word, double. What this means that whatever is written out in front of the method is what is returned by the method. So the power method calculates something and it returns the answer as a double, which means it's a decimal number. So what came out of this was a decimal number, 9.0. Now notice that in the definition of the method here, it said it required double A and double B, which are 2 decimals. But I didn't actually give it decimals. I gave it a whole number 3 and a whole number 2, which are like integers. So the math library is smart enough to know that when I pass integers, it'll do that conversion into 3.0 and 2.0 and give me the result in terms of a double variable there, or a double number. So for instance, I could do 3.0 and I could do 2.0, and I'm going to, of course, get exactly the same result. I can do 3.25 raised to the power of 2.87. So 3.25 raised to the power of 2.87, and the answer I get back, of course, is going to be a double precision number, because that's how the math libraries are generally structured, is to return double numbers back. But it works just fine if I put whole numbers in, because behind the scenes, Java's doing the conversion and casting it into a double before it does the calculation. So if I do 7 and raise it to the power of 2, then I expect to get 49, because 7 times 7 is 49. If I raise it to the power of 5, I expect a much larger number back, and in fact I get 16,807. So I'm passing numbers here in, but just remember, you can declare any variables, doubles, or integers, or whatever, and you can pass them in as variable names rather than just these numbers here. So you could be doing a calculation with some variables that would then yield an answer, and I can store the result in some other variable as well. So that's how to handle powers. If I'm doing 10 squared, 10 to the power of 3, 10 to the power of 4, whatever. Oftentimes we also would like to calculate the square root of something. Square root is something that we frequently need to do. So let me jump back into here and I'll show you where that is. If we scroll down, Eventually we're going to get to SQRT, which tells you it returns the correctly rounded positive square root of a double value. So it's telling you that you should pass into this method a double, which is a double variable, double precision variable, and the outcome of that should be a double. But again, in many cases in Java, if you pass it an integer, it'll be smart enough to cast it into a double, do the calculation, and give you the answer back. So let's test this here. Math, capital M, and then SQRT. Notice it's trying to tell me there's a method called square root that requires a double. And then in there, I can just say 4. Now, of course, it says it requires a double, so I'll put 4.0 inside of there. And then I should get an answer of 2 because the square root of 4 is 2. Now, if I take this decimal point away, let's see if it works. Works just fine because Java knows that whenever I'm using these math functions, frequently I'll give it a whole number and it'll just put a invisible decimal point there, converting it to double prior to the calculation actually being done. So you can put anything in here, 935, take the square root of 935, for instance, and I'll get a number with lots of precision after it. Now the question remains, or I guess I shouldn't say the question, but the statement remains is that it returns the correctly rounded positive square root. All right, remember you learned from math class that when you take the square root of something, for instance, 4, there really is there's always 2 answers. So in this case, let me go ahead and hit run here. We're getting the positive 2. Actually, the other valid answer here is negative 2, because negative 2 times negative 2 also gives you a positive 4. Well, Java doesn't handle that. It doesn't give you the other result. It only gives you the positive square root answer. It's the same thing that you would get out of a calculator. So just make sure you understand that. The other thing is you learned a long time ago in math class that square roots of negative numbers don't work too well. So for instance, if I put negative 2 here, hit save and run, notice it says NaN. So if you ever say NaN, it means not a number. And that's basically saying that the result of this calculation doesn't give me a real number back. The key word there being a real number. If you go in more advanced math classes, you'll find out that you can take the square root of negative numbers all day long. What you get is something called an imaginary number. Well, this is a programming language. It deals with a real number, so you're not going to be doing complex, or I should say imaginary number math with the math libraries here. If it gives you a positive real result, it'll give you the number. If it gets into something that it doesn't know how to do or requires imaginary numbers to give you the answer, it's going to give you something like NaN. So bottom line, you cannot take square root of negative numbers in Java. So that's a basic idea of how you calculate the powers, anything raised to an exponent of something else, and also how to calculate the square root of numbers in Java.